Alright, so we are going to be looking at versatile assigner and the double validation method on a solid state NMR protein. This is GB1 protein. The first thing you're going to want to do is open up versatile assigner, of course, which is two-letter code VA. We'll get this window here. You can set if you'd like to use nitrogen information on the top here. The sequence file here in the middle needs to be set, or of course you can always use two-letter code SQ and set your sequence file for the project, which will also work. Following that, under the append buttons here, we have the walking direction. You're going to want to select which direction you're walking in. This is going to make your predictions much more accurate and decrease the time it takes for you to get a validation in the first place. So at any point in your spectra, you can pick any peak that you might have, and you need to get some strips linked. I would suggest at least 6 strips, 6 residues, which would be 12 strips since we have 2 experiments here. It generally takes 3 residues for a single validation, which means we're going to need about 5 or 6 in our double validation. That number can vary. It could be as low as 2 or possibly as high as 5. So just keep that in mind while you are finding these strips. So what we're going to want to start out with, we'll go back to versatile assigner. Yes, we are also going to need to open our reference views, which is two-letter code IR, and that is going to pull up our 3 reference views. We have 3 reference views. The first one here is the carbon alpha and beta of each amino acid, and you can see that you will get a crosshair on this depending on your carbon dimension. So there we go. We can see that some of these peaks are clearly certain types of carbons. Super clean ones here, but that's all right. So I'm going to go ahead and minimize that. You do need it open in the background, but I can minimize it. Here we have a reference view for hydrogens for each amino acid. And then finally here we have all of the carbons instead of just carbons beta and alpha. So go ahead and minimize that. Now we are all prepared to start this. So you're going to come to your first residue, and you want to select its carbons alpha and beta here and here. We're going to go ahead and click the predict button on top. This is going to give our predicted amino acids. We are only going to pay attention to those above 5%. So looking through the list here, we can see that we have 4 possible amino acid assignments. But of course, with 1 residue, we aren't going to get any sequence because we have no sequence. It's only a single residue. So we're going to go ahead and append all of those above 5%. That's going to put it in our history, the I-1 history. And we're going to move on to our next residue. So here we can see, looks like those 2 are carbons alpha and beta. We're going to predict. And we can see alanine here. We've already got a validation that is E19 and A20. This is the only place in our sequence which goes E followed directly by an A, is E19 and A20. So that is a validation right there. I am going to go 1 more residue just to make sure. So I'm going to push down our history and append above 5%. That's going to be our new I-1. Our original I-1 is now going to get pushed back to I-2. And I'm going to go 1 more strip ahead. We're going to check this one out. So here we've got carbons alpha and beta are there. We're going to go ahead and predict that. We're going to go see nothing to show, so this clearly can't be a P given all of these different permutations of what these 2 might be. But our V does work. So we've got E19, A20, V21. This is a 100% chance. The only other amino acid prediction that is above 5% is the P, which is not compatible with our history. So this must be an EAV. Now, this is a single validation. To double validate, what we're simply going to do is clear and then append this information as the start of a new subsequence, which we are going to validate. So we will move over here. Just get that guy right there. And we are going to continue on with the second validation. So onto our next strip here. Let's see, it looks like this and this are carbons alpha and beta. We're going to predict. This is clearly not an L, but it is a D. However, we do not know which D. It could be V21, D22, or it could be V39 and D40. Now, clearly, from the first validation, we want this to be a V21, but this is the importance of double validation. This could end up being V39. And if it is, that means that this section of our spectra is not agreeing with the original section of our spectra. And if those two don't agree, well, then there must be either a faulty residue in here, one that is not being predicted correctly for whatever reason that might be, or more likely the strips are not the correct ones in sequence with each other. But in any case, we do not have 100% here, so we're going to go ahead and push down our history and append that, and we will move on to our next residue, which we have there, and there is our second carbon. We're going to predict this, and here, there we go. So with the addition of there having to be an alanine coming following, there we can validate that this is in fact V21, D22, A23, and this lines up perfectly with the previous ones which ended in V21. So with all of that information, we can validate that this section of the spectra, these must be the correct assignments. So once you have validated those things, if you would like to assign these carbons directly from Versatile Assigner, we can select whichever carbons you'd like. I've gone back here to D22, and you simply predict those. You're going to get these up here. Remember which one that you are on. We are on D22 right now, and you can come down here to in your sequence, the I residue, and find the correct place in your sequence for this amino acid. D22 is right here. I'm going to go ahead and double click on those. It is going to add that label directly on there. And you can keep doing this forward or backwards. You can also come here to your CAN, CO, CX, and you can label directly from Versatile Assigner on those as well. You can do this for all residues that you have previously and all residues in the future if you continue to assign with Versatile Assigner. So I hope that helps.